Greetings to one and all. This is another lecture of the first unit of machine learning, in which we'll see a few additional concepts related to mathematics and statistics, and some related to the implementation using pandas libraries in Python. Now, if we talk about standard deviation, standard deviation is considered to be a measure of scatteredness of the data points around the mean of the data points. For example, if we consider the heights of persons as depicted on the screen, then this is said to be the mean of all the heights. If we want to find out the mean of all the heights, we need to add all the heights divided by the total number of heights. That is 18 plus 8 plus 15 plus 8 plus 9 plus 6 divided by 1, 2, 3, 4, 5, 6 divided by 6. This is equal to 155. Now, this is 155. But this extra height, this whole thing is 155, but this extra height is nothing but 155 plus 18. Hence, the amount of height which is extra above the mean or the height which is below the mean. For example, this person's height is less than 155 by 8 centimeter. So this difference of the height from the mean height is said to be a factor that is used to calculate standard deviation. So if we go for the formula, then standard deviation is given by the formula square root of 1 by n summation of each observation minus the mean of that observation. So for example, if we take an observation in which this particular height is what? 155 plus 18. So it will be 173. So this particular height is 173. And this particular height till here is 155. Hence, the first observation that we need to take is square root of 1 upon n. And then xi will be x1, suppose 173 minus the mean, that is 155, and the square of that, plus the next observation, that is 8 centimeter less, that is 155 minus 8. So 155 minus 8, that is 147. This particular height corresponds to 147. So we will take the mean minus 147, the whole square. That means the mean minus each observation, square of that, and divide by n, where n is the total number of persons or elements which we are considering, which is 6 in this case. So here it will become this square plus this square and so on divided by 6. This is when we consider population as to calculate standard deviation. So total we have 6 members, and we are calculating standard deviation for 6 members only. However, if there are so many members of which we do not know the actual count, there are many members, and out of these many, we are taking only, suppose, 6 people. That means out of many, we are taking 6. That means these 6 people are a representation of this entire population. In such a case, if we are taking a sample, this is called a sample of the entire population. When we are taking the sample, the formula becomes 1 upon n minus 1. So whenever it is sample, we take n minus 1. And whenever we are considering population, we take it as n. Sometimes population may be less, suppose 15. That time we'll take n as 15. But if population is in lakhs or millions, that time we consider sample as a representation of the population, and that time we take n value as, instead of n, we take n minus 1. Now, we'll see why we take n and why n minus 1 in case of population and sample respectively. Now, there's another term called as variance. And by observation of these two formulas, by observing these two formulas, we can say that variance is nothing but the square of standard deviation. Variance is the square of standard deviation. Now, Suppose we talk about the reason behind why n minus 1 and not n. Suppose we have a set of books. Suppose we have a set of books. Suppose 5 books. And we know their average weight. Suppose average weight is A. Then we also know the weight of book 1, X. So if we eliminate this particular book, then the remaining weight will become A minus X. Remaining weight of these books. So instead of average, if we consider A to be the sum of weights, we are taking A as the sum of weights. So if we know the total sum of all 5 books, we know the weight of the first book. Then if we eliminate the first book, then the weight of all the remaining books will be A minus X. Now, if we know the weight of this particular book, we eliminate this. Suppose the weight of this book is Y, then weight of the remaining 3 books will become A minus X minus Y. And then weight of the remaining books, again, we keep on subtracting. And when we reach for the last book, we know that the weight of the last book is nothing but the sum. So in such a way, it is observed that when we know the total weight, and if we know individual weights, then we don't have to find the weight of the last book, right? If we know the total weight and we know the weight of first, second, third, fourth, then we automatically come to know the weight of the last book. So that means we have to do the computations n minus 1 times. And that is why we are taking n minus 1. So you can give a thought to this process and you'll definitely realize. Now, if we consider outliers, so these are the values or data points which are out of the range comprising of other values. For example, these may be extremely low or extremely high in comparison with the other observations. These cause the machine learning model to yield inaccurate results. For example, if age of all the students in the 5th grade are recorded and they are in the range 10 to 12, and suddenly abruptly one student has the age of 89 years, then this is maybe due to a human error while recording the ages. But due to this outlier or this invalid input in comparison with the range of other values, we'll have some inaccuracy in the prediction. So this is outlier. Now, in order to detect such outliers or such invalid values in the observation of the data set, what we'll do is we can use 2 methods. One is using standard deviation. Just now we have seen standard deviation is a measure of randomness of the data points. So it is the deviation of the data from the mean value. So if we consider standard deviation may be of order 1 or of order 2 or of order 3. Now, what do I mean by standard deviation order means? Suppose standard deviation is a value which is in this particular range. So suppose standard deviation can be plus 1 up to minus 1. Suppose we consider twice of standard deviation, then maybe we can multiply this by 2, then it will become plus 2. We can multiply this by 2, it will become minus 2. Then if it is thrice the standard deviation, we can go for plus 3 up to minus 3. That means in the range of standard deviation, that means in the range of plus 1 to minus 1, we will have all the values. Suppose we have the values like 0.1, 0.2, and 0.5. And also some value like minus 0.4. Then all these data points are within the range of the standard deviation. But suppose we consider the values like minus 1.51, then we consider 0.7, then we can say that this value minus 1.5, does not fall in this particular range -1 to +1. This value -1.5 will lie in the range +2 to -2. That means it lies in the range of twice the standard deviation. Similarly, some points may lie in the range of thrice the standard deviation. So in this way, we can consider standard deviation once or twice of it or thrice of it. Now, if any point exceeds thrice of the standard deviation range, suppose we have a value like -9, it does not fall even in thrice of the standard deviation. Then such a value -9 is considered to be an outlier. Okay, we may consider only as per the application once of standard deviation, twice of standard deviation, thrice of standard deviation, but still beyond this, if it is going, it is an outlier. These are some assumptions we make based on the data and the data source. So here we are going to see it in a program. For example, we are going to import NumPy as NP, matplotlib.pyplot as PLT, and statistics is also another library that we have. And we'll develop a particular list of data points, or you can say a NumPy array of data points. So we'll have multiple points over here. Now, randomly, we are going to generate from, say, 0 to 49999. In this particular range, randomly we'll generate some data points, multiply them with 20 and plus 20. Just for some calculation, we are using the data in this particular range. We'll print this array. So these are the values that we are getting. Now we need to find the outliers. So for this particular data set, we need to find outliers. Now, let us call the outliers as anomalies or abnormal values. Now the upper range, let us set the maximum upper range. That is, we know that we have standard deviation once in this particular range. Then we can have standard deviation twice in this particular range. And then we can have standard deviation thrice in this particular range. So this is our 3 times of standard deviation in the negative side. And this is our 3 times of standard deviation in the positive side. So let 3 times of standard deviation positive be the maximum on the positive side and 3 times of standard deviation negative on the lower limit. So if we write, we calculate the standard deviation using we are calling this function stdev, and we are passing this data. We are passing this data for calculating its standard deviation. And then we are also calculating the mean of this. Okay. Now, whatever the standard deviation we are getting, we are multiplying by 3. So that we can take the lower limit as, suppose A is equal to thrice of standard deviation. Then minus A will be the lower limit and plus A will be the upper limit. Do you agree with me? If we have 3 times of standard deviation stored in A, then minus A will be lower limit, plus A will be upper limit. So also, if we find out the anomaly cutoff over here in the previous slide was what? I have called it as A, but actually that A is nothing but anomaly cutoff. I have written here, see, I have written that A is equal to anomaly cutoff, which is thrice of standard deviation. I've written it here. So instead of anomaly cutoff, I called it as A. So here, our whatever mean is there, minus the A will give us the lower limit, and whatever mean is there, plus A will give us the upper limit. Now, for every value in the data, so we have a list of values like B, C, D. So for every value in data, if this is data, then for every value in this data, if that data is greater than upper limit, or if that data is lesser than the lower limit, then it is said to be an anomaly. As I mentioned, if this is your graph, this is your lower limit, this is your upper limit, then anything to the left of this lower limit and anything to the right of this upper limit is said to be an outlier, which we are going to append inside this anomalies array. And then finally, we'll return this anomalies array. So this is one way. Using multiples of standard deviation, we can identify whether we have outliers or not in our data. Same can be applied to the columns in the data frame. Now we can have another way to detect outliers, that is called as box plot. So in case of box plot, they are the graphical depiction of numerical data through the different quantiles. Okay, if we consider graphical representation, then this particular line is said to be the minimum value in a particular list. We have multiple values in a list. Out of these values, the minimum is said to be represented by this line. The maximum of the values is said to be represented by this line. Then we have something called as first quartile, second quartile, and third quartile. Okay, for these particular values, we need to plot a particular such diagram. Hence, for this particular box plot, we can call this thing as the lower whisker. This entire is called a whisker. This is called as upper whisker. This is the upper quartile. This is the lower quartile, and this is the median. So generally, this first quartile is represented as 25%, second quartile as 50%, and last third quartile as 75%. So let us see this in detail. So if we consider this as our box plot, then this is our minimum value in the list of values. This is our maximum value in the list of values. Then this is said to be median. That means the middle element. Suppose we have the values like 5, 6, 7, 8, 9, 10. Then the number of values in this, that means the length of A is 1, 2, 3, 4, 5, 6. That means if the number of elements is even, length is even. If number of elements is even, then there are two middle values. By observation, we know that 7 and 8 are the two middle elements. So the formula to find out the middle elements, the median, is that median is equal to n by 2th element plus n by 2 plus 1th element, and the mean of that. The mean of the two middle elements is said to be the median, in case the number of elements is even. So here we have 6 elements. That means the median will become equal to 3 plus 4 by 2. That is 7 by 2, that is 3.5. That is 3.5 is the median of this particular set. Now suppose we have odd number of elements. In case we have odd number of elements, for example 5, 6, 7, 8 only, then this time the length of this is 5. That is, now the number of elements is said to be odd. If there are odd elements, then the median is said to be given by the formula of n plus 1 by 2, 2th element. So n plus 1 by 2th element is nothing but 5 plus 1, that is 6 by 2th element, that is the third element. And the third element is 7, which is actually the middle element. Now, for odd number of elements, we have a single median element. For even number of elements, the median is equal to average of the two middle elements. And always remember, median is found on the list only if the list is sorted. If the list is not sorted, then first sort the list and then find the median. So this is the median. That means another intuition is that median, this is the middle line, which is represented as 50%. The meaning of this 50% is that 50% of the values in the list is less than the median. That means 50% of the values in the list is greater than the median. Hence, this is the diagram of the box plot. And the values that we need to find are Q1, which is median of the lower half of the data. That means if we consider our data to be A, B, C, D, E, F, G. And if D is our median, then median of this lower half is said to be the 25% median. Median of the entire data set is this median called as 50% median. And the median of this upper half is said to be the 75% median. Okay, so if you want to find out Q1, it is nothing but the median of the lower half. If we want to find the median of the entire data set, it is called as Q2. And the median of the lower half, that is of this particular part, is said to be Q3. So this is the first quartile, second quartile, and the third quartile. Now, the value of interquartile range. Value of interquartile range is found by Q3 minus Q1. Q3 minus Q1 gives us the interquartile range. And how to find out the max and min value? The minimum value is a value which is equal to or greater than Q1 plus 1.5 into IQR. And maximum value is a value which is less than or equal to Q3 minus 1.5 IQR. Now, we can take a sample example. For example, suppose our data consists of 1, 2, 3, 5, 6, 7. Now we know that the median of these numbers lies over here. That means the 50% median is nothing but the mean of 4 and 5, right? 50% median, or you can say median of the entire data set, is the mean of the two middle elements. That means mean of 4 and 5 is 4.5. That means the 50% median is 4.5. Now, the median of the lower half, that means the ones which are lesser than the 50% median, the median of these many values will be 2.5. And the median of these many values will be over here, that is 6.5. So now we have the values of Q1, of Q2, and of Q3. Now interquartile range can be found out by Q3, that is 6.5, minus Q1, that is 2.5. That will be 4. So IQR will be equal to 4. Now minimum will be a value which is greater than equal to Q1 plus 1.5 into IQR. Now Q1 plus 1.5 into IQR will be, so if we consider to find the values of min and max, minimum is a value which is just greater than equal to Q1 minus 1.5 into IQR. So if we calculate Q1, which is 2.5 minus 1.5 into IQR is 4, then we'll get a value minus 3.5. So any value which is just greater than or equal to minus 3.5, the very first such value in the data points will be the min. So here, the very first value, which is just greater than minus 3.5, is over here, 1. So this will become min. And the value of max will be just less than or equal to the value of Q3 plus 1.5 into IQR, which is 6.5 plus 1.5 into 4, which comes out to be 12.5. So a value which is just less than or equal to 12.5 is 8. And this is our max. Hence, this is our min and max. 4.5 is the median of the entire data set. 2.5 is the value of Q1. And 6.5 is the value of Q3. Hence, any values which are beyond the max, that means any value greater than max, or any value which is lesser than min, these values and these values are said to be outliers. Because min and max of this data points, we know Anything going beyond this particular range between min and max is said to be an outlier. So this is box plot, which is used to find out certain aspects such as 25% median, 50% median, 75% median, and the interquartile range, and the min and max of the data points. And any values outside the min and max range is said to be an outlier. Now, if we want to eliminate the outliers, we need to use something called as clip function. Clip function. Clipping means if we are going outside the range, then do not exceed that range. And if we are going below a particular range, do not go below that range. So clipping has to be done. For example, again, we are generating randomly, this time not random, we are generating a particular range from, this is our lower limit and this is our higher limit. So the range that we generate, the values that we get will always be within this particular range. Okay, the values that we get will always, by this particular function call, the values that we'll get will be starting from 10, 11, 12, and going so on up to 99. That means the value can be up to 100 minus 1, that is up to 99. We'll get some values. For example, I have printed the value of A that we have computed over here. On printing A, that is before applying any kind of clipping, this is our list. That means we are getting values 10, 20, 30, 40, 50, 60, 70, 80, 90, because we are having a step size 10. That means you consider this particular range, and each time the value should be after 10, means multiples of 10. For example, first value will be 10. Next value will be 10 plus 10. Next value will be 10 plus 10 plus 10. So in this way it will happen. Let me write it once again. So first value, we are starting from the lower limit 10. Next value will be the previous value, whatever is the previous value, plus step size. This is called as step size. Then the next value will be 10 plus 10, that is 20 now. Whatever is the previous value, which is 20, plus another step size 10. The next value will be this particular value, which is 30, plus another step size 10. The next value will be the previous value, that is 40, plus another step size 10. So if I solve this, the values that I'll get will be 10, 10 plus 10, that is 20, 20 plus 10, 30, and 30 plus 10, 40, and 40 plus 10, 50. Okay, so these are the values that we'll get on solving. So step size is nothing but previous value plus that step size. Next value will be previous value plus step size. The next value will be previous value plus step size. That is where we are getting 10, 20, 30, 40, 50, 60, 70, 80, 90. Now, if we consider clipping, it is a function that we can call from the NumPy library, in which you need to pass all the list of elements, the lower limit and the upper limit, which are allowed. So lower limit which is allowed is 30, and upper limit which is allowed is 60. That means all the values falling in this range are allowed. All the values falling in this range are allowed. So any value which is less than 30, like 10 and 20, which we have in our data set, will be raised to the lower limit. As you can see, 10 is raised to the lower limit 30, 20 is raised to the lower limit 30. And any value which is greater than this upper limit, like 70 80, 90, they are lowered to the upper limit. They are lowered to the upper limit, which is 60. They are lowered to the upper limit, which is 60. So any values before the lower limit of the range become the lower limit, and any values which are above the upper limit of the range become the upper limit. Right? I hope you are able to visualize how we are clipping over here. This is a way by which we can clip the values if they are going beyond the range. So if we consider box plot, this 30 is our min and this 60 is our max. So outliers are being made equal to the min and max. If they are before the min, make them equal to min. If they are after the max, make them equal to max. I hope you understood this clipping function. Now we will understand correlation. Which is denoted by the letter R. So correlation analysis deals with association between two or more variables. For example, if we have two variables, X and Y, in this particular data frame, then we need to understand how X and Y are related. And we know that X is our feature and Y is our label. So we know that Y is dependent on X, that is Y is a sum function of X. Okay, Y is dependent on X. So we need to observe the changes in X, and accordingly how Y is changing, we need to find out, which is given by correlation. The degree of relationship is measured through correlation analysis. And this R, that is the correlation coefficient or correlation index. R indicates the degree of correlation, or it is called correlation coefficient or correlation index. Now here we can observe that if 10 is increasing, if 10 is increasing, Y is also increasing, as you can see. 12 to 15, so 20 to 22. Again an increase in Y. An increase in X, an increase in Y. That means there's linear relationship of incrementation between X and Y. Or maybe in another kind of data set, X is increasing, but Y is decreasing. Now X increased, but again Y decreased. Again X increased, again Y decreased. Again X increased, but again Y decreased. That means X and Y are inversely proportional, and here X is directly proportional. Y is directly proportional to X. So there are two types of correlation. One is called positive correlation, and one is called negative correlation. Positive correlation means both the variables vary in the same direction. Means if one is increasing, if X is increasing, then Y should also increase. This means they are in the same direction. Or if X is decreasing, then Y should also decrease. This is decreasing. For example, if a person's height is increasing, means if he's growing, then normally his weight also increases. So height and weight show positive correlation. Or greater the rainfall, more is the yield of the crops. Positive correlation. Or we can have negative correlation also. Okay, so this is increase with increase or decrease with decrease. Now we have a particular thing called as negative correlation. If both the variables vary in opposite directions, means if X is increasing, then Y is decreasing. Or if X is decreasing, then Y is increasing. Means inverse proportionality. For example, if the price of a commodity keeps on increasing, then people will not buy it. So its demand will decrease. So as price increases, the demand decreases. This is an example of negative correlation. So same direction change is said to be positive correlation. Opposite direction change is said to be negative correlation. Or positive correlation is also called as direct correlation, and negative correlation is also called as inverse correlation. Now, if it is positive correlation, the value of correlation coefficient will go from 0 to 1. And if the correlation is said to be negative, then the value of R goes from -1 to 0.